Next up on our set of tasks is adding in a DMZ network to our infrastructure. So oftentimes when you are running a small, medium, or really whatever size business, there's a good chance that you're going to have some servers and some appliances accessible to outside hosts. So good examples would be maybe you're running an email setup for someone else. You need clients tying into that. You might also just have a web server with your company page that you want external people to access. So what I've added into the network is a switch and two servers. We've got them connected up to Ethernet 7 on the firewall, and the previous configurations of having a VPN between this internal site and the internal site over here at the UC, that still exists. What I'm going to try to go through is getting laptop 20 to be able to hit a web page on server 10. So we're going to have to go through and set up the NAT, the access lists, as well as the interface configuration for a DMZ interface. So we're going to go ahead and start on the DSU firewall, and we'll jump right into that and start with that interface configuration. Now when I do a show IP address, we can see the interfaces that I currently have configured are just VLANs 1 and VLAN 2. So we're actually going to add in one more VLAN, and that is VLAN 3. Now before we get too far into that, we do need to look at our licensing limitations, because we're going to run into a small problem that's going to be fairly easy to fix. But if I do a show activation key, we're going to see that we have some limitations here. What we're looking for is our VLANs. And you can see we have a maximum of 3 VLANs that we can use, and it's DMZ restricted. Basically what's going to happen is when we create the DMZ VLAN, we're going to have to disallow our inside hosts from accessing that. It's kind of a weird requirement. We probably wouldn't do that in the business, but since we're limited by the license, we have to work around it that way. The real fix, of course, would just be to get the Security Plus license where that limitation is removed. So I'm going to go into config T, and we can set up that interface so I can show you what the problem will be. When I go to interface VLAN 3, it lets me create it properly, but as soon as I try to name it, so if I'm going to name it DMZ, we get basically the error message saying this license does not allow configuring more than 2 interfaces with nameif. What I have to do to fix that is add in the no forward command. So we're going to go no forward interface VLAN 1. Now doing that's going to allow me to finish this DMZ configuration, but again, my inside hosts will not be able to talk to the server in the DMZ. Probably not an ideal setup. After we have that done, we can change a few things like the security level. So 50 is kind of your default level for DMZ, 100 was your inside, 0 was your outside, and remember that you cannot go from a lower trusted interface to a higher without rules. So it's security level of 50, and we'll set up an IP address on it. What I had chosen for this network was 10.0.1.1, and just a normal slant 24, and that should be all we need for that part. Now the second part of getting this interface configured, if you remember right, on the 5505s, all of our interfaces operate as VLANs, or basically layer 2 ports. So what we need to do is add in our layer 2 switch port into this VLAN to get it to actually route this traffic. I can verify that if I go to show switch VLAN. You can see my inside interface has the first 4. My second VLAN interface has the second 4 ports. So we're going to add in our Ethernet 07, so we're just going to move that from the outside to the VLAN. That's where that switch is plugged into. So we're going to go to config T, and we'll go to interface Ethernet 07, and just set it to switch port access VLAN 3. Perfect. When I look at those VLAN memberships again, with a show switch VLAN, you can now see that we have Ethernet 7 and VLAN 3. And I just noticed here we don't have a name with it, so let's go quick, put that name on the interface. It'll be a lot easier in our configs down the road. So one more time around, going back to config T, go to interface VLAN 3, and there we can set our name if DMZ. Perfect. So we're looking good there. The next part about setting up a DMZ is we deal a lot with firewall rules, and we're also going to deal with NAT. Now this is a pretty small firewall configuration, but just for the sake of best practice, we're going to get in the habit of creating object networks, so we could treat several different subnets the same way. We also create object hosts, so we can identify the web server by name rather than being bound to an IP address. The idea behind that is if we change it in the future, all we have to do is update the IP address in one place, and the name of that server will stay consistent throughout the rest of the firewall. It's kind of like using a variable in programming. So we can go ahead and start out with that configuration. We'll just create a few different object groups, and we'll kind of see how those work. So back into config-t, we're going to create a few object networks. The first one is going to identify the internal IP address of the web server. So object network, and we'll just call this web01. That might be the name of the web server, but that'll be fine. Within there, we're going to identify the inside IP address. So this will be host, and the IP address that I chose for it was 10.0.1.10. Next thing I want to do is create the external name for the web server's IP address. So I'll go back into config-t, object network, web01 ext, so just signifying external. The host, so the outside IP address will be 138.247.80.3. Now we could tie this back directly to the 80.1 IP address that used to be on here, but it's kind of fun if we had a little bit bigger range, how we can start to segment this stuff out. A reason you might want the web server on a different IP address than your firewall's main IP is if you have something like the web VPN or the ASDM exposed, you're going to be fighting over which port and which web app should be served. So let's set this up as 80.3, and we'll need to go adjust our inside IP addresses. So when I do a show run, what we can see here is just the VLAN 2 is only set up for really one usable IP address on this firewall, one on the other one. So I actually want to switch that to use a little bit bigger subnet. So let's go back into VLAN 2, let's go to config-t, interface VLAN 2, and we'll change the IP address to be 138.247. We'll leave it as 80.1, but we're going to make that subnet just a little bit bigger to kind of make this more realistic. So we'll give it a 248. And while we're thinking about it, good idea to go fix it over here too on the UC firewall. So exact same thing, going into config-t, interface VLAN 2, and we'll just expand that subnet out a little bit. So IP address 138.247.80.2, and let's make that a 248. Okay, so back over to the DSU firewall, keeping track of what we've set up here. I just created the object network group that represent the internal and external IP address of what I want this web server to be communicating on. The next thing that we're going to do is identify our subnets with objects as well. So I'm going to back out of the interface configuration, and we'll create some of those objects to identify our subnets. So I'm going to have an object network. I'll call this DMZ subnet. Instead of specifying a host here, we're going to identify the whole subnet. So this will be subnet, and my DMZ happens to be in the 10.0.1.0, and that was a slant 24. Okay, next thing we're going to do, jump back into config-t, and we'll create an object to represent our inside subnet. Where we're going with this is we're going to need to use NAT for both the inside subnets and the DMZ subnets. So by making these groups, you'll see when we get to that part of the configuration, the NAT is actually quite a bit more simple. So creating that second object network, we'll go object network, and actually maybe we'll do inside subnet, and we'll call the subnet for the inside network 192.168, rather 10.0.0.0. Just thinking about the wrong side of the network, so this is actually the inside subnet here. So our objects we just created over here, this was inside subnet. Down here in this green box, this was DMZ subnet. Those groups just represent what networks exist in each of those. All right, so we've made it through most of the difficult parts here. What we're going to do is we're going to start creating some access lists to allow this traffic in, and then we'll go set up the NAT configuration that we're going to need here as well. So jumping back into config T, we'll create the ACL to allow web traffic coming from the outside, so anywhere on the internet, to be permitted to the 138.247.80.3 address. Later, we'll hook up NAT in the back end to tie that to the internal web server. So right now we just have to allow web traffic into our network. We can tie it to the back end a little bit later here. So the access list we're going to make, we'll just do an extended access list. So access list, I might call this outside in. This will be an extended ACL, and we're going to permit traffic. What type of traffic are we going to permit? In this case, it's going to be TCP traffic. I don't care where the source is coming from, so I'm going to choose any source. Our destination, here's where our objects start to come in handy, is going to be web ext. So anything coming into that external web server over TCP, we're starting to allow. And we could get even a little bit more precise with it if we wanted to, and you could do like an EQ80 to specify only HTTP traffic. I'm going to leave it as it is for now, just to kind of keep things simple here. And I think this was actually web underscore, actually web01 ext. There we go. So I had the object group wrong. Okay, so that should be permitting that web traffic in. Let's go hook up the NAT configuration in the back end. To do NAT, we're actually going to have to go back to those object networks where we identified the subnets. You could have done it in one step, but we'll see when we do this configuration, it actually splits it out and it makes it a little bit easier to read. But it is an extra step to have to go back into those to set up the NAT configuration. So we're going to go back into our object network, and we had DMZ subnet. I want to make sure I used a hyphen here instead of a dash. Otherwise, we'll be dealing with the wrong objects. So yeah, it looks like DMZ-subnet. And the NAT configuration is really simple. We'll do NAT. We're coming from DMZ going to the outside interface. So kind of allowing the DMZ subnet to get back out to the internet. And we'll call this a dynamic interface, basically saying we're going to configure patch for this, and we'll tie those to the outside interface. Okay, so that was DMZ subnet. We also need to go to the object network inside subnet, and the NAT configuration is the exact same, so we'll do NAT. Instead of DMZ though, we'll do inside. We're still going to bind it to the outside interface, and dynamic interface allows us to use the PAT configuration. Now the very last part, we need to do a static NAT mapping. So we're going to bind that 138.247.80.3 public IP address back to the 10.0.1.10 internal IP address of the web server. Depending on the version of ASA that you're running, this command can be slightly different. So what we're going to have here is we're going to go back to our object network, web01. So this is where we identify the internal IP address of our web01 server. We're going to say NAT. This exists on the DMZ. It needs to be tied to the outside IP address. But instead of doing a dynamic interface, we're going to do a static mapping. So static, and we'll go 138.247.80.3. Now in the full-blown version of ASA, we could have actually used the static object of web01-ext and used our actual variable or the object for that. Packet tracer, we have to just use the IP address for it, so no big deal. Regardless, the NAT configuration on that should be set up properly. Okay, so time to test here. A couple things are going to come into play, especially when you're setting this up. It's a little bit tricky. So in Packet Tracer, it's really nice that we actually can watch these packets go across the network and see how they're working. But the theory behind this is, since we're doing a stateful connection, it's a TCP connection from laptop 20 to our DSU VPN head end, we should not really have to mess with firewall rules on this. We'll see how it works out. But basically, when this firewall over here at DSU gets a packet that's a TCP packet going to 138.247.80.3, it'll see the NAT mapping and push that back down to the web server here. So let's give it a go, and we can troubleshoot once we find out whether or not it's working. So we'll go to 138.247.80.3. We'll kind of wait here for a second. It's probably going to time out this first go around. So we can kind of start to figure out where we've got maybe an issue or a problem with that. What I'm going to do is I'm going to flip over to the time simulation, kind of show you this again. It's not something we spend a ton of time in. I'm going to clear the filters out, and we want to look at specifically HTTP as well as TCP down here. It might be a little bit off the screen for you. But you have HTTP and TCP here. When we go into the laptop again, and we type out 138.247.80.3, we're going to go to it, and we can just kind of start to walk through this network and see where we maybe failed at, or where do we need to add in additional firewall rules. So we will step it forward. I'm going to speed this up just slightly as well. So you can see our packets making its way across the network. It reaches the firewall, and we get the angry red X. So more than likely, it's going to be something with a firewall rule or a NAT translation over here. When we click on that packet, we can kind of walk through and see where we're starting to have an error. So it made it through the layer 1 delivery. The layer 2 part of the packet was fine. When we get to here, we start to see some of the problems. We had the device translation from the global to local addresses with the NAT translation. When our firewall looked up the inside IP address in the CEF table, there was no entry for that IP address. So what we start to see as we go through that is we're looking at the basically the routes or how we can get to that internal IP address. We can see that it's connected. We've got the problem of the ASA not allowing any traffic from that lower security zone back to the higher security interface. So that would be like the from the lower zones would be something like the outside interface or the DMZ going to like an inside host. So let's take a look again at our firewall rules and just see if we can figure out where we would need to add that back in. So let's go back to our firewall here and see if we can tweak that rule just a little bit. What I'm going to do is I'm just going to do a show access dash list so we can see what we've got. Now we had all of the VPN rules, so we don't need to worry about those too much. What we were more focused on here was this section, the outside in. Now the first thing I want to do when I look at these rules is first kind of check apart, of our source and destination, if that's all correct. But we also need to add it to a interface, which is I think where this went off a little bit. If we do a show run, we can see if that ACL is actually applied anywhere. And it doesn't look like it, so that's probably a pretty good place to start here. Let's actually activate that ACL. So from config-t, we'll go access-group, and the name of the ACL is outside in, and we just need to add it as an in on the interface outside. Okay, so the ACL should at least be active now. Let's try this one more time here and see how we do. It's kind of this iterative process of tracing your packets down, and actually in the real ASAs there's actually a command that's packet-tracer that shows you very similar stuff to what we saw in the simulation mode. Of course, a little bit less detailed, but you would still be able to decipher what was actually happening there. So this time when we go to 138.247.80.3, let's actually just relaunch this. Okay, so we've still got a timeout, so let's go back again. We will trace this packet and see if our firewall made any difference or where we're getting hung up now. Okay, so stepping through again, we'll watch that packet actually hit the firewall, and we're still having a bit of an issue there. So let's see if we can capture that and see what was actually happening. So again, as we step through this here, we make it through layer 2. The packet does not match any criteria of the outside in access list, so it's denied and dropped by default. So what we have to do now is look at the inbound PDU or that inbound packet and start to figure out what the source and destination looks like, and if we can figure out why the packet is not matching. So source 192.168.1.20, that should have been covered by the any source. Our destination 138.247.80.3, we can double check that in our rule. So if we do a show access list, so here we see our outside in. It's an extended permit. It's a TCP packet. We don't care what the source is. It's going to the object of Web01 on the external interface. So it looks like it's getting 3 hits, but let's kind of check out anything else that might be giving us a bit of an issue. Our source and destination ports 129 or 1029 and 80 shouldn't make too much of a difference between those. So let's just step one more time. Okay, so let's try one more thing here. I'm going to do a show run. We'll take another look at that firewall rule. Let's maybe see if it's upset about our object. So let's copy this. We'll go back into config T and walk this rule one more time. We can maybe use the actual IP address here. So we will do a permit. We knew it was a TCP packet from what we just traced. We don't care what the source is, so we're going to leave that as an any. The destination, let's try this time. We'll do a 138.247.80.3. And we actually want the word host in front of this, so we don't have to type out the wildcard bits. And we'll give that a shot. So again, going back to our real-time mode, let's test it. 138.247.80.3. And another timeout. Okay, so back to our simulation here. Hopefully we can get this narrowed down. And we'll step it forward, so we'll see how far we're getting this time. So it looks like it's making it to the firewall. So forward progress anyhow. Hits our web server, comes back up. Back to our firewall, and we're getting a deny here. Okay, so at the very beginning of this, I said this shouldn't matter because we're using a stateful firewall. Firewall should be keeping track of the outgoing connection that we've permitted from that inside interface to the outside, but we can check when we look at this if that's actually happening or not. Okay, so we're not hitting any statements in the ACL, so it looks like our packet's being denied and dropped. Okay, and the only ACL that we have there is the allow VPN traffic. So let's do this kind of maybe a band-aid fix for what's happening here in Packet Tracer. But when we're on this firewall, we can create an access list kind of similar to what we just did over there on the DSU firewall. So I'm going to create an access list. I'm just going to call this outside in as well. I'll do extended permit. And I'm just going to say for now we'll just do a TCP. I guess we don't really probably care where that's coming from because it should be kept track of in that state table. So we'll make it in any rule for now. And I'll say to any destination, which is, I get it, a very wide open rule. But like I said, this should be maintained in our state table. So I'll do a permit any. We will apply that to our interface here. So again, we'll go access group outside dash in. This will be incoming to our interface outside. Okay, so let's maybe just try this one more time here. If we walk through again, and there we see it came back to us. And I think it should be okay. So let's try in our real time. And there we can see the page finally came up. So a few kind of unexpected detours throughout this, but I think it's good also to see how we can kind of watch those packets and some of the challenges that are come up with that process. Right, so we can kind of lean on the packet tracer simulation for part of our troubleshooting. But again, in the real environments, we'll have the packet-tracer command that shows us a lot of that same information. Now, the other two quirks that I want to cover again, and I think this is more of a packet tracer issue, is what we just fixed, having to add in that ACL rule to allow the web packet to come back in. Normally, you shouldn't have to do that because of a state table and our stateful firewalls. The other thing over here on the DSU VPN head end, we had a little bit of a problem when we created the Web01 ext object. Packet tracer wasn't seeming to like that when we used it down here. Now these last two lines in this ACL are the exact same, the only difference being that we used an object for one, which was a host, and we actually specified the real IP address down here right below that. Couple caveats that you might run into, but I want to show you kind of both ways how this really should work and kind of what we're running into with this software. That's all I've got for this one. Hopefully should kind of complete your VPN and DMZ type of setup.